Good afternoon, everyone, and welcome to Seed Speaks. This is a video series brought to you by Seed World Group. My name is Rebecca Carmeli Peslak, and I'm the digital media producer for Seed World Group. Today, we are talking about how often are meteorologists right. Weather is extremely important to the agricultural sector, but it can be extremely unpredictable. How are meteorologists forecasting the weather, and how often are they right? This week on Seed Speaks, we'll be hearing from experts in the weather sector to learn more about the accuracy of the forecasts they make. Our expert panelists will share background information on the data they use to predict weather, as well as the time and training they put in to be at the positions they are in now. Learn about the accuracy of weather predictions and how often meteorologists are right during this episode of Seed Speaks. Today, I am joined by three experts to discuss how often meteorologists are right. Allison Plumador, meteorologist at the National Weather Center, Scott Keller, president and chief scientist at Weatherlogics, Inc., and Matt Dixon, senior meteorologist at the University of Kentucky Ag Weather Center. Allison, Scott, and Matt, thank you so much for joining me today and bringing your expertise to Seed Speaks. Matt, could you please briefly introduce yourself to our audience?
Yeah, so again, my name's Matt Dixon. I'm a meteorologist with the UK Ag Weather Center. I started in 2012. Lucky for me, it was right in the middle of a drought here in the state of Kentucky. But basically, our goal in Ag Weather Center is to minimize weather and climate-related surprise for Kentucky farmers and producers. We're a part of cooperative extension, so we're essentially the bridge between university research and resources to the Kentucky community. So again, been helping out farmers, producers with forecast since 2012. It's a little different. We take the weather information, we translate that to drying conditions, spraying conditions, livestock heat stress, cold stress, you name it. So taking that agricultural aspect to the forecast. But on the side, also working with the university, I help out with winter weather cancellations. I work part-time for UK Athletics. Forecasting weather for our football games. If lightning gets within 8 miles of the stadium, of course, we have to postpone activity for 30 minutes or so. But yeah, that's a little bit about me. So,
Thanks, Matt. Scott, could you also introduce yourself to our audience today?
Hi, everyone. Scott Kaler from Weatherlogics. I'm the president of Weatherlogics and a meteorologist based in Winnipeg, Canada. At our company, we work with a lot of farmers providing weather forecasts for their farm all across the Canadian prairies and northern United States. We do things like predicting rainfall, thunderstorms, and things like snow at this time of year. Our company also does a number of other things in other sectors, work for governments, insurance companies, and so on. And recently, we launched a free weather app. So Weatherlogics is available in the App Store. And these different things are all geared toward providing more detailed information that's specific to a particular industry, farmers being a big one. But when we're talking about this time of year, we're also dealing a lot with snow, especially across Canada. Although right now on the prairies, it's been an unusually dry fall and early winter. So not a lot of snow so far, but that could change anytime. So looking forward to talking more about our work and how often meteorologists are right.
Thanks, Scott. Allison, could you introduce yourself, please?
Hi, my name is Allison Plumador. I work for the National Weather Service in the Weather Forecast Office down in the Florida Keys. We service all of the Florida Keys, and we basically issue warnings and let people know in the now what's going on. We want to create a weather-ready nation, so we will provide forecasts for the short term and the long term. And with that, we kind of let everyone know what's going on with the weather for the Florida Keys.
Thanks, Allison. Matt, if you don't mind, I'm going to start the first question with you, and then Allison and Scott, feel free to chime in. How long have you been predicting the weather, and what training did you do to get to where you are today?
Yeah, again, since 2012, with my arrival here at the University of Kentucky. Prior to getting here, I went to Purdue University, got my undergraduate degree in atmospheric sciences. I then went on to Mississippi State University and received a master's in geosciences with concentration in applied meteorology. So about, I guess it's 6 years worth of schooling before arriving at UK. But, as I tell everybody, it's that on the job experience that's very important in this profession.
Thanks, Matt. Allison and Scott, either one of you can go ahead. I'd love to hear more about your training and how long you've been in this role.
Yeah, I actually also went to Purdue and got my undergrad in atmospheric science. And I stayed there and got my master's degree in geodata science. And then once I got my job, I've been there for 2 years now. It's almost 2.5. And I did an intensive radar course where I learned how to properly issue warnings. So for your local area, someone just like me will sometimes, if you get a tornado warning on your phone, that's something I learned how to do. I also did some trainings for our airports. We issue a terminal airdrome forecast. So for that, it's a forecast for about 24 hours saying what the winds, the cloud coverage, if there's going to be rain or not. We issue those for both of our airports that we have in the Keys, as well as I did marine training to learn about kind of how the oceans work so that we could issue some coastal water forecasts. So we tell people what the seas are going to look like, what the winds will be doing, things like that.
Awesome. Thank you so much for sharing that, Allison. Scott, do you want to share your side of things?
Sure. I started forecasting when I was just a kid. I was fascinated by weather from a young age. And so when I was not even in university yet, I was already forecasting. So that dates back all the way to 2007. So I've been producing weather forecasts for about 16 years now. And because of that interest I had as a kid in weather, I ended up doing a bachelor's degree and master's degree at the University of Manitoba in atmospheric science. And in both of those degrees, I did a lot of research. So in my bachelor's degree, I studied the weather around the Manitoba lakes. If you look at a map right in the middle of North America, we have two huge bodies of water, Lake Winnipeg and Lake Manitoba. So I studied how those bodies of water affected weather. And then in my master's, I really had a great opportunity where I went down to Kansas in the summer of 2015 and I studied convection. And by that, I mean basically thunderstorms. And we were studying how thunderstorms develop at night. And so I went back, took the work that we did in Kansas and applied some of that work to Canada because for farmers, thunderstorms are a big driver of rainfall during the growing season. So I spent a lot of time doing that. And then once I graduated, I started WeatherLogics, the company I'm at now. And so that's kind of a brief history of my work in the field.
Awesome. Thank you so much. My next question is, what is your most accurate tool for predictions? And I'll start this one with Allison.
Yeah, so one of my favorite tools to use is the GOES satellite data. So they just came out with a new one that they launched in 2016. It has more than a dozen sensors. 3 of the sensors that I use daily are the water vapor, the infrared, and the visible satellite imagery. The water vapor kind of gives a good idea of like general circulation patterns, moisture in the atmosphere. It's kind of like the big picture. And then the infrared measures the temperature of the objects it's seeing. So it can see like low level clouds, upper level clouds, tall thunderstorms, organizing tropical cyclones. But visible satellite is definitely one of my favorites because it's got great detail. You can see even like fog banks, you can see wildfires breaking out. At times, you can actually even see a reef off the Florida Keys, which is pretty cool. The resolution is as fine as like almost half a kilometer, which from 22,000 miles up above the Earth, it's very accurate and really awesome.
That's great. Thank you so much for sharing. Matt, Scott, your most accurate and favorite tool?
Well, I think for me, there's so many great tools out there now. Satellite is one of them for sure. Radar is another. For me, I've always loved modeling because we now have such sophisticated weather models where we can predict weather down to a scale of just a couple of miles. And that's not to say these weather models are always correct, but they're such a useful tool for trying to analyze what's going to happen next. At WeatherLogics, we have a model that we've produced which combines so many different data sources together, and that gives us a really good average picture of what's happening next. And so that's something I use all the time. I wouldn't say it's the only tool, but it's one of my favorites to use. And all of the data from our modeling is available in our WeatherLogics app. So now it's available for free to the public to take a look at as well.
Awesome. That's so cool that you can share that out. Matt?
Yeah, I like what Scott said about the combination of resources available to us. Of course, we get the high resolution weather models, we got the satellite data, high res data that Allison was alluding to, the radar data, we got ground truth, we got weather balloons being launched into the upper atmosphere. But the combination of these products is what ultimately makes that accurate forecast. And whenever we're talking about the most accurate meteorology tool, like something I've been working on recently is I'm getting ready to teach the spring semester here at UK in biometeorology, and talking about our advances in technology here recently. And I don't know if you can see this, but this is a little slide from a projector back in the 80s. And again, a little hard to see, but it shows the pixelation of radar back in the day. And just looking at current radar now, it's light years ahead of where we were. And it'll be interesting to see where we're at 10, 20, 30 years from now. So I'm sure it'll be totally different when I retire. So
That was very interesting. Thank you so much for sharing that. I guess leading into this next question, you mentioned, Matt, that forecasts are more accurate the more data you use. So how many different types of data do you use when you're making a prediction?
that's a good question. And, everything I just alluded to, but something that's unique here in the state of Kentucky, several other states have added these networks in the past, but Mesonet networks. So it's a network of roughly 80 research quality weather stations here in the state of Kentucky. We can take this data and ingest it into these weather models, help us forecast out in the future. They also help us, with the National Weather Service, as Allison was alluding to, another way to determine maybe if a severe thunderstorm warning needs to be issued for a particular location. So the addition of these Mesonet networks across the United States has been great over the past decade.
Awesome. Scott, Allison, how many different types of data, what type of data do you use when you're making your predictions?
Well, I think how much, it's really just how much your brain can handle at once, because there's far more data out there than you could possibly use for a single forecast. But when I make a forecast, probably the main things that I'm looking at would be some of those that were already mentioned, like weather radar, satellites, weather models, sometimes weather balloons. It also depends on what you're forecasting. So let's say in wintertime, looking at weather balloons is often very important to see what the temperature profile is and whether or not the snow might melt or become freezing rain, or whatever the case. Also in summertime, if you're forecasting thunderstorms, you would look at weather balloons more. So it depends on what you're forecasting in terms of what tools you would use. But there's so much data that exists today. You just have to try to take in what you think is most important, because you could never look at all of it.
Totally. Allison?
Yeah, I definitely agree with both of them, where it's kind of like, in a sense, you're a doctor where you like, what's going on? What can we do about it? Here's the solution. So it's like, what's the atmosphere doing right now? What's going to happen? Things like that. And actually, I did launch a weather balloon last night. So that is definitely something we use down in our office too.
Allison or Scott, since both of you mentioned weather balloons, in case our audience isn't familiar with that, could you explain a little bit more about what that is?
Yeah, I can speak on that. So basically, a weather balloon is attached. It's a big balloon that's attached to a radiosonde that we send up into the atmosphere, and it collects data. So it collects the pressure, the temperature, how much water is in the air, all of that as it's ascending into the Earth. Basically, it gets pretty high up in the sky, and then by the time it pops, it's actually so high up that it's so cold it just shatters into a million pieces. So I know a lot of people think, oh, this giant balloon is falling back down to Earth, but it's actually not. And our radiosondes do land somewhere, and they have our phone numbers on them, and you can call the office and return them. We've actually had a few returned to us, which is pretty cool. But with that data, we can look at a bunch of different information. Our main thing we look at is the skew-T, which shows the temperature and the dew point, looking at what's going on throughout the atmosphere, and it actually gets ingested into a lot of different models and helps form different maps that you can see where systems are going to go and things like that. So it's got a lot of great things that can be used for it.
Thanks so much for
And
filling us in on that. Oh, look at that.
This is the instrument that's attached to the balloon. I don't have the entire balloon, obviously, but this is what actually takes the measurements. I kept this because this was a failed one that I launched.
We
Oh,
actually
thank
have
you so much. That's so
a newer
interesting.
version of that just came out. I learned how to launch on that one you're holding. We recently just got an upgraded version that's a little smaller and lighter, so we don't have to use as much gas when we launch.
Very cool. Thank you for filling us in on that and showing us an example. So, I guess my next question is, how unpredictable is weather?
Well, I always tell people it comes down to the time frame, because if you want to know what the exact weather is going to be at 1 p.m. a month from now, that's not possible to know. But what the weather is going to be like in a few hours from now is very certain. So the unpredictability of weather increases with time. In the next few hours, it's very unlikely a meteorologist would be surprised by the weather that's happening. Tomorrow's weather is also fairly predictable. Occasionally you are a little bit surprised by what happens, but not very often. And then the farther you go out in time, the more unpredictable it becomes, to the point where if we're talking months in the future, really at that point, we're just talking about general trends, like will it be warmer than normal or wetter than normal? We're not talking about really the details. So it all comes down to the time frame. But it's really not as unpredictable as people think. It's not like all of a sudden some storm just shows up at our doorstep, half an hour from now that we had no idea about. It all comes down to how far in advance you need to know these things.
Thanks for that, Scott. Allison, Matt?
Yeah, I would agree that obviously closer to time, it's pretty certain what's going to happen. Now we do have climatology, so we can look out into the future and say, well, the last 30 years, it rained on this day. It could maybe rain on this day again, but obviously that far out, it's not as certain as it would be within a week is usually where we say our sweet spot is.
Totally. And Matt?
Yeah, so some forecasts are definitely more complex than others. I totally agree with Allison and Scott. The closer in time you are, the better it is. But like things such as winter weather, I'm here in the Ohio Valley. We can see various different types of wintry precipitation, whether it's sleet, freezing rain, snow, just plain rain, and it just depends on a variety of factors. What's your surface temperature like? What's the temperature like, in the upper atmosphere? Is there a dry layer? Is there a warm layer that could potentially melt that wintry precipitation? So, yes, there's some very complex forecasts out there, but essentially the closer you are to the event, easier it's going to be.
Awesome. Now, my next question is, when you guys are making these forecasts and predictions, are you keeping track of how accurate they are?
I'll start maybe. Yes, we do. And I think pretty much every major agency would keep what we call their verification records to see how accurate the forecast was. Now, these can be measured in so many different ways. I guess that's kind of the challenge, is how do you measure the forecast accuracy in a way that the average person would actually be able to use? We use all sorts of weird metrics, like what's the error in the 500 millibar height field, which people listening are probably wondering what on earth was he saying. I mean, that's not a very useful metric for the average person to look at when comparing accuracy of forecasts, but that's a common one that meteorologists use. But in short, yes, we do keep track of it in many different ways, and that's really important to determine where we need to improve and what we're already doing well.
Awesome. Allison, Matt, anything to add there?
Yeah, for verification, exactly what we call it too. So we kind of look at like ground truth for that. We have different sensors. The FAA actually requires sensors at their airports, so we can look at that just to kind of see what weather rolled through there. There's a lot of private residencies that have weather stations at their homes, so we can kind of look at the data they collect there. We have wave sensors on our buoys and things like that, and we can see also like satellite derived sources for like wind speed and wave height as well. And then we have a lot of people down here who actually like to have rain gauges, and they will report to us what they got at their houses, and we can kind of compare to what our forecast was.
Awesome. Sounds like you have a helpful community. Matt?
I mean, yeah, you have to take into account where you went wrong. This is not a perfect science by any means. We have these models out there, even the high resolution models. We have to make some assumptions and keeping track of what went right in your forecast, what went wrong in your forecast will just help you the next time you got to create a forecast. So
I think this is a good leadway into an audience question that we got, which is, what do you say to people when they complain to you about the weather and say that your forecast didn't get it right? Anyone can feel free to take this one to start.
I mean, it's what I just said. I mean, the atmosphere can be chaos, and I work with farmers and producers, and um, they understand. Again, it's not a perfect science. We could have hay down the field. We don't want to see rain for 4 days or whatnot, but there's a chance we miss an isolated storm, and it happens. So again, it's not perfect.
I don't know. There's one thing that I say. It really depends on the comment. A lot of people just like to joke about, how meteorologists are people that can be wrong most of the time and keep their job. But I think meteorologists have a thick skin, and you just don't take any of that personally. And the reality is, we know that when it comes to predictive sciences, we're probably the best one. I mean, if you could pick stocks as accurately as we could predict the weather, I would not be a meteorologist probably.
Thanks for that, Scott. Allison, anything to add?
Yeah, I agree with both of what they said. Just kind of got to have the thick skin because people like to joke about it, but we know what we're doing is we are the experts, so we try not to take offense to it when people make those jokes.
Totally. I have a fun question now. What is the most exciting weather for you personally to cover? And
Well,
also,
for me, it's always been thunderstorms. That's always been my passion. I love to watch thunderstorms. I sometimes storm chase for fun in the summer if I have the chance. And so for me, that's always the most interesting. And I find also the most difficult weather to predict is probably thunderstorms. And when it comes to farmers, thunderstorms can give them that really important rainfall during the growing season. So we try our best to predict when thunderstorms will happen, but they're probably the most challenging to predict, especially when it comes to how much rain they'll produce. But that also makes them very interesting.
awesome. That's so cool that you're a storm chaser in your spare time. Allison, Matt, most exciting weather?
I would say for me, probably hurricane season with tropical weather is probably my favorite just because everyone kind of comes into the office. It's an all hands event. We get to really talk to the community. We get very spike in phone calls and outreach on line, and we get to really put all of our brains to the test and get in there with it. And I actually got to forecast with the Jacksonville office for their airports, and I kind of got to decide when the airport opened after the storm went through and when to close it before the storm went through. So that was a really cool experience for me.
That's awesome, Allison. Matt?
I think severe weather is probably at the top of most meteorologists' list on most exciting weather to cover. Winter weather is probably up there also. But going back to severe weather, of course, Scott talked about chasing and whatnot, and that's always been an interest of mine also. But I, I don't want to, take a downhill turn on this conversation. But for me personally, like the past couple of years in Kentucky, it's been awful in terms of severe weather. We had the longest track tornado to ever occur here in Kentucky happened December 2021. It was on the ground for it was like 165 miles throughout the state. We had big time flooding across eastern Kentucky. Communities just wiped out. So as much as I like severe weather, once you go out and see the impacts to the community, I'd much rather be in San Diego at that point with I'll say a plain weather pattern in place. But yeah.
Thanks for that insight, Matt. And that wraps up my questions for today. Big thank you to Allison, Scott, and Matt for chatting with me on today's episode of Seed Speaks. I really enjoyed learning from all of you, all of your weather knowledge, and being able to share this information and your expertise with our audience. Next week, tune in to Seed Speaks to hear from Ashley on predicting the weather with the Farmer's Almanac. Thank you again to everyone for joining us, and have a great week.